It's the end of an era more than 1 billion kilometers from Earth this week as the Cassini spacecraft plunges to its fiery death in the clouds of Saturn. I'm Mike Lemonick.
And I'm Lee Billings.
When I was a kid, long before you were born, the best view we had of Saturn was from the Palomar telescope on Earth, and it was kind of murky and fuzzy. And things got better. We sent the Pioneer and then the Voyager spacecraft. But for the past 13 years, we've had a fantastically better view from the Cassini.
Which looks a lot like this. This is a scale model. It's a little worse for wear after 13 years around Saturn, you might notice. We actually built this here in the office. But as its name suggests, the orbiter orbited Saturn and gave us a much better view of its rings and moons and the planet itself than anything that came before.
And those discoveries really have been amazing. We should start with the planet. Cassini found, for example, this crazy hexagonal-shaped storm that covers most of Saturn's North Pole. Nobody imagined anything like that. And what about the rings?
Saw unprecedented details in the rings. Density waves propagating through them, little embedded moonlets tumbling to and fro, sculpting and shaping the rings, all kinds of wonderful detail. But you know, Mike, the real most important discoveries are definitely more about the moons rather than the planet or its rings, I believe.
Right. So they found some moons that look just crazy close up. There's one that looks like a walnut, and another one looks like a sponge, and there's one that looks like a pierogi.
There's one that even looks like the Death Star from Star Wars.
It's pretty crazy.
It's pretty wild.
But all of those are just kind of funhouse events compared with what we found on a couple of bigger moons, Titan, for example.
That's Saturn's largest moon, and it actually might be a little like Earth used to be billions of years ago. It has a thick atmosphere, much like Earth's, but it's much, much, much colder. And instead of having a hydrological cycle like we do on Earth, it has a methanological cycle. There's liquid methane there instead of liquid water.
And it rains down from these clouds, and it creates rivers and seas and sculpts the land through erosion.
And we know a lot more about it now, not only from Cassini, which was able to peer through this murky haze of smog down to its surface with radar. It was also able to deploy a little tiny lander called Huygens, built by the European Space Agency, and deliver actual images from Titan's surface, which is wild.
Right. And then the real excitement is at Enceladus.
Enceladus, this 500-kilometer wide, tiny little runt of a moon that people thought was just going to be an inert ball of ice, turns out it's actually something much more.
When they arrived in 2004, everybody was shocked to see water and ice spewing from the surface in these huge geysers out into space. And those geysers get their start, we believe, from a subsurface ocean.
That's right. And now we know from data from Cassini that not only is there a subsurface ocean, but there's also hydrothermal activity at the bottom of that ocean. The same sorts of hydrothermal activity, hydrothermal vents that exist on Earth and its oceans that might have been the cradles of life on this planet.
And that is why Enceladus is by far the most promising place to look for life beyond Earth in our solar system.
And that's why Cassini's mission planners decided to crash the spacecraft into Saturn rather than risk contaminating this target of immense astrobiological interest with microbes from Earth.
So the last thing is what NASA is calling the grand finale. Let's show them how it works.
So first, Mike, imagine that this little rubber ducky is Cassini. This little ball is Saturn's largest moon, Titan. And Cassini slungshot around Titan to get into a trajectory that makes it go between the innermost ring of Saturn and the planet's cloud tops.
That's someplace nobody's ever explored before, and it can answer some really important questions.
Important questions like the length of Saturn's day, something we really don't know yet, and that's linked to basically its atmospheric dynamics, how weather happens on Saturn. But probably the coolest thing we're going to be learning about Saturn from the grand finale is maybe the age of its rings. People believe that there's a linkage between the mass of the ring system and its age, with younger rings being less massive. And it looks like, based on the latest data we are getting from Cassini right now,
the rings might be only 100 million years old. The dinosaurs, when they were walking around, might have looked up and they would have seen Saturn without any rings, if they had a telescope.
So we should feel pretty special to be here now, looking at these beautiful rings, having this spacecraft there to investigate it all. And it's really come up with a lot of wonderful discoveries. There's still many mysteries about Saturn, many things drawing us back. We don't know when we'll return, but it's given us a lot of reasons to go back. But for now,
that's the end of Cassini. The actual ending will be much more fiery and dramatic. I'm Mike Lemonick.
I'm Lee Billings.
Please subscribe to our YouTube channel. Well, that's that.
We really should have burned it.
I know. They just wouldn't let us.
It's more accurate.